This is kind of a nasty looking function, huh? And so it says it's bounded below by g and from above by h. So where is this pushing you to think? I'll give you a hint. It comes from our last section.
Is it where if the limit of g of x and h of x are the same, then the limit of f of x is the same as the
Yes. As long as we know that it is bounded from below and above, meaning it's pinched, squeezed, or sandwiched between, right? And it's not like we know exactly what these look like either, but because we're told that statement and that statement, we know that it's pinched in between. So I'm going to use the version that we wrote. So it's squeezed between. So that was one condition of our squeeze theorem, which we're going to continue with today. So the first condition is it has to be between those two functions. Then the other condition was the bounding functions have to have the same limit. So we talked Tuesday about if there's a gap in between, we can't say the limit for sure is that value because it could do something we don't know in between. So basically we set up our limit sandwich. So we're bounded below by that version. And where are we going? 0. So x approaches 0. This time I'm just, this is by the way, a good piece of advice. If a function is defined in the problem statement, you don't have to go rewrite it all in your work. So we see that f is defined right here, so it's okay to just say f instead of going and writing that whole thing. And then over here we're just finding the limit on either side. Of our function. Okay. We have no idea how to find the limit of the f of x function. It's certainly with our algebraic tools, it's not going to work. But because we were told that it does meet the first condition, it's squeezed in between. Now we can just find these limits. How would we do that? Yeah, there's nothing indeterminate, right? So there's no difficulty, no funny business. So this limit is just negative square root of 1.11. And then this one, of course, is going to be the positive square root of 1.11. Once we plug in for x, and x is 0, it's just the x's go away. So what can you conclude from that?
Cannot be determined.
Yeah. So these don't match. In terms of writing it out, we have to say the squeeze theorem does not apply. Or cannot be used. Let's use that language. Because the gap is too big. So our function is passing through there, but we don't know what it's doing as it passes through because of this too big of gap. It's not pinched together tight enough, maybe we could say. Okay, so this cannot be determined. Limit as x approaches 0 of f cannot be determined. So the question at the top is bounded enough. What do you say to that? Bounded meaning we know it's trapped on top and bottom. Is that enough? No, we have to meet both conditions, which means the limit has to be the same as well. Okay. Questions on that one? So just to address, we usually check homework roughly at this point, and you're working on your review for the quiz. Any issues with that? Is that going okay? It's on AP Classroom. Okay. I think it is due right now. Hopefully you finish this. I can't remember. I think I have it due like right now. I'll talk more about the quiz here in a little while. So grab this sheet. Let's go ahead and finish. And we'll talk a few more random slides. And then we're going to talk also about 1.9 today, which is not necessarily new. It's just a different look at what we've done so far. So this is 1.8. Give you the context. You're looking for this page in your packet. Do you guys like this format? Is it working for you? I figure it's kind of nice to be able to go back and flip and find exact topics, especially like when it's February and you're looking back at limit stuff that's been 6 months ago. It'll be nice to have titles and see it, right? Alright. Just to clarify, we kind of rushed this. I got the algebra mixed up and fixed it at the end. So I just want to make sure you're clear that we wrote the limits 1 and -1 that the cosine function is bounded by. So because cosine has this x squared out front in the given function, we had to multiply those two limits by x squared to make it algebraically equivalent. And I had divided. So I'm just making sure you caught the fix. So when we multiply, now we take the limit as x approaches 0 on both sides it's 0. Therefore, the limit of the function is 0 because that one does get pinched enough, right? It's smack on top of each other. Okay. Do you guys know this symbol? In math, in math we like to abbreviate practically everything. And it's the symbol for the word kind of implies. It's like an equal sign with an arrow on it. Okay. Let's look at these ones down at the bottom. I didn't write the rest of this one, but I think most of you told me you got 3 for this, but just to check. Did everybody get that? Like these two become 3 on the sides, and of course you need to write in your limit notation, but the limit is 3. I'm just going to write that unless you need me to finish writing everything. Are we all good on that one? Okay. Right, well then looking down at the bottom. So f, g, and h are functions defined as given there. Why does it say this, x not equal to 0? What's that saving us from? Well, yeah, kind of, but also just algebraically wrong, right? We can't have a 0 denominator. Okay, all of the following inequalities are true. So we don't have to go try to prove anything. They are true. State whether each inequality can be used with the squeeze theorem to find the limit of the function. So before I tell you, what do you think your approach for this is? It's asking, can the squeeze theorem be used? So it's really a yes or no answer, right? Maybe with some justification. So what do you think? Yeah.
You can plug in like a value for x and see if it comes out the same.
Yeah, essentially we're just seeing if those two squeeze limits are the same, right? So you'd want to write out good notation. What is the limit as x approaches 0 of -1/2? Yeah, remember that's our limit of a constant. And I'm going to bend this around the corner. I'm not going to write this out every time, but I just want to write the correct process if you had to do this on an FRQ. So the limit as x approaches 0 has to be written on each component of the inequality, of the compound inequality. Then we can go evaluate. So we said this is -1/2. And we have not evaluated the limit yet for f. And then how about this one? Like what's the limit as x approaches 0 of the right hand function? Huh? It's just 1/2, yeah. So can we use the squeeze theorem for that? That's just like the warm-up, right? Where we say no, etc. The squeeze theorem cannot be used because the limit of both the bounding functions is not the same. Maybe I'll write that out just in case when you're looking back here in February. Everybody good if we abbreviate ST for squeeze theorem? How did you guys do with your justifications on your pre-calc test, do you know? Bounding functions do not have the same limit. Okay. Alright, how about the next one? Or actually, why don't you guys do the next two? Feel free to just pick one of them to write out and just on the other one just say yes or no. Just to practice your justification.
Did I say that right?
I don't want to write everything out, but you're going to end up with this for that one. So does the squeeze theorem work? Forgot the G. Yeah, because those bounding functions have the same limit. And remember, we had to be told that the inequalities are true. If we didn't have that stated up here, then we wouldn't be able to do this. Okay, and then here you're going to get 1 and hx and 1 over there. So yes on that one, yes on that one. Your justification would say basically the opposite of this. So yes, the squeeze theorem can be used because the bounding functions have the same limit. Any issues with that? Okay, it's a lot of practice writing it out, mostly. Alright. Let's look at another one of these kind. We know the answer is no, bounded is not enough, but let's just keep looking at AP style questions related to this content. Are you ready to try this? I don't want to read it to you and take that opportunity away. Can we just try it? Yeah? You guys are so talkative. Guys, once you've done these a few times, you can kind of start to see that as we approach 0, we have 0 bounding f. And so obviously that one works. Why does this one not work?
Because they're not the same. Or they won't both equal 0.
Well, and the limits are not defined, right? Like this one, 1 over x. There's nothing we can do to simplify that algebraically or anything. Same here. So there's no manipulating around an undefined limit. So that one does not exist. And then this one, we go back to plugging in 0, and we just get e and e. So yeah, good. I feel like you're getting the squeeze theorem. Do you feel like you are? All right. So last topic that is covered on your quiz, and we're going to come back to that, but is multiple representations of limits. So far we've looked at graphs, tables, and then function rules. And so this is where we get the chance to see if that has sunk in, I guess you could say. So we'll do a couple of these and then a couple of AP style, and then hopefully that'll make you feel like you're ready. Here's a pretty typical type of question. So if f is a piecewise function with 2 linear pieces, and I'm going to tell you, I'll write this on another slide as well. When you do these kind, actually I'm going to even write it this way. Caution. When you do these kind, you need to read super carefully. So I'm going to tell you that now, and then on a slide or two ahead, see if it sinks in. Okay, such that the limit as x approaches 5 does not exist. Which of the following could be representative of the function f? So it does not exist. One should be jumping out at you. Is it? Yeah, the graph. Why? Let's go back and use some limit language. Why does the limit not exist?
Because the two lines don't meet at the same point. You
Okay.
have to have the limit from the left or the limit from the right.
There we go. The right hand and left hand limits have to match, right? So we have to have agreement between the one-sided limits. So yes, this could be. Okay. Again, just read carefully because we're saying which one could not exist, and sometimes I think as you think through these, your brain might flip it and say, okay, which one can exist, that kind of thing. Just be clear on what the question is asking. Okay, so let's go to these more detailed, like we have to get into it a little bit more. How do we do a piecewise limit, piecewise function limit? You guys remember from last week, I think.
You
Yeah.
get like really close to 5. So like you do like if you're coming from the left, then you do 4.999.
Okay.
And then
You can do that. It's a little easier though than that. Like what? I mean, we have this piecewise. It's very clearly saying less than 5 and greater than 5. Isn't that the very definition of one-sided limit? Like, who cares what 5 is? It's coming from the left and from the right. So how do we evaluate limits for a piecewise?
Because it doesn't say it's equal to 5.
We can just plug in 5 to the left hand and the right hand piece. Okay? So it sounds like you probably need to write that to tell yourself. So plug in 5 to the left and right piece. Pieces. Alright, so let's write it out kind of official looking. Limit as x approaches 5 from the left. Which one do we use? Top one. 2 times 5 minus 1 equals 9. And then limit as x approaches 5 from the right is just 14 minus 5, which is 9. So can this be our function? No, because it is 9. We have a limit. The limit is 9. Okay. Alright, tables are where you're going to find the most tricky ones. And this is where you need to be careful. So we need to look and make sure, number one, that we're looking at the limit pattern, or the pattern to the limiting value, and we need to make sure that it is actually linear in the first place. You guys working on that assignment, maybe do it later. I can give you more time if you need, but I'd rather you get this. So let's take a little note first. For tables, check. We're going to make a list. Check. 1, that the table actually matches the description of the function. Here's what I mean. If this says linear and I look in the table and it's not linear, then it doesn't work, right? Or maybe that would work if depending how the problem is, how it's worded. But you got to start there. All right, next one. Make sure, well, let's say it this way. Use the pattern in the table. This one is where you have to be really careful to get the limiting value. Okay, and that stands in contrast, let me raise this up. Not the value of the function. In the table. Okay, why don't you write that and then process it for a second and then I'll explain. Okay, here's what I mean. So for this one, it says linear pieces. So we know we're looking at the limit of as x approaches 5. So we're looking here. Is this a linear pattern?
Yes.
So it's if we look at x's, it's just going up by 1, and this is going down by 2. So that's linear, at least as much as we can tell. And then 8, 7, 6, 7, 8, and then actually let's go backwards. 8, 7, 6, that's by 1, and this is down by 5 each time.
Yes.
So it is linear. And then part 2, use the pattern to get the limit, not the value. So you kind of want to look at this and say the limit is 1. But the pattern wouldn't suggest that. Here's what I mean. And this pattern tells us what should the value at 5 be.
Oh.
Yeah, says 4. And the other pattern, going backwards, pattern says what?
1.
Okay? Says 1. So can you visualize what's going on here? 10, 8, 6, 4 from the left. From the right, 16, 11, 6, 1. If we're dropping by 5 each time. So yeah, he's doing it. Can you picture a graph if we think graphically? Like coming from the left, we're hitting at 4. Coming from the right, we're hitting at 1. So that's a good jump discontinuity. That's could be our function, right? Like it does not exist because it's coming from 2 different directions. So this one, yes. Limit as x approaches 5 from the left is 4. And I'm making this very clear in case you want to come back and look at this later. Based on the left pattern of -2 each time. I did the colors wrong, sorry about that. Limit as x approaches 5 from the right is 1, and that's based on the right pattern. On the pattern from the right, which is down 5 each time. So you can see there's some subtlety here. Do you agree? Like if you don't take time to look at this closely, you might miss the table. I think out of the 3, it's definitely the most tricky.
Here I was just going to say it goes up each time.
No, well, but the limit coming from the
Oh, okay.
right is coming into the number 5. Yeah. Yeah, good. He's pointing out that, like, if we read this from like an algebra perspective, obviously we're counting from left to right, and it's increasing by 5. But thinking from limit mindset, we're coming in to 5 from the right, and it's counting down. So if that wording doesn't work, then reword it for you, because you see it. I know you do, but I'm just saying it different.
Can you scroll down?
Yeah.
Wait, so here, are we going to drop like certain aspects of algebra in this class?
What do you mean?
Like you say, we don't have to like solve certain things completely algebraically.
Well, I mean, I don't know about solve, but we've already done a lot of algebra on our limits, right?
Yeah,
So
just, you said we don't need to like, they're not looking at the numbers.
Oh,
like,
I
if
see
we
what
have
you're
a thing, yeah.
it depends. Most of the time, that's true. I don't. I'll have to think about it. There's times when you can't, when you should, but generally they're not worried about like simplifying a fraction. You know, like if you did 10/4, you don't have to make that 5 halves. Did you get what you needed? Everybody else, you good? Okay. You notice the next part of this is absolute value limits, which we already did, so I'm not going to do it again unless there's questions on it. Do we need to?
No.
Okay. So let's look at some of these ones. I'm going to let you try the next few slides before I talk about them. Which two can you kick out immediately?
Eight.
Define 2.6.
Yeah, like we know the limit is, or the value, I mean, of the function at 4 is defined. And we know it's not 2.16, so we can kick those out right away. Alright, and then how did you distinguish between these two? Because we're coming in above 1, right? Is that what you're going to say?
I was gonna say the values afterwards, after the 4.
Yeah.
That's exactly what happened.
Good job. Okay, and then let's see, let's make this one bigger. And I have to move my little green circle. So read that word carefully. And we'll take another minute or so.
And there are
Alright,
8 letters.
so checking this one. Again, looking at the pattern is a little bit of a pain, but what are we doing going to the right from here? What are we doing going to the right? Like from 0.139 to 0.141
Increasing.
by 0.02, right? And then coming backwards, so like our next value would be 0.143 if we follow that pattern. And then how about this way? Dropping 2, so this would be 3.140. Does the 2.7 matter? Do we know what happens in between there?
No.
Okay. We don't know what happens in here. So read that circle, that green circle. Could this have a limit that does not exist? Because of what I just wrote there. Yes, we could not, like this thing could do something crazy in between. And so yes, this could be the table for a does not exist limit. So we know A is going to be, or 1 is going to be one of these. Okay, thinking test strategy, if we know that 1 is okay, we can kick out answers B and B. Oh, not D, B. Alright, next one. What is the limit from the left?
6.
1 from the left. Of F equals what?
9.
9. And then the limit, this is giving us some practice doing our piecewise limits from the right. 6. Okay, so this one definitely works. So that kicks out A. So testing strategy, we now know that it's either C or D. So what about number 3? Does it work? Okay, so this one you just have to read really carefully, because if you just glance at it, you're like, hey, that limit doesn't exist. But we have to come down here to the 1, and the limit definitely does exist there. So this is going to be C. How'd you do? Okay. All right, next one. AP likes, does not like all that apply, so this is not really an AP version. You know what, I think I'm just going to zoom this with the projector. Yeah, in AP questions you don't have like multiple answers. Unless it's like the one we just did where they give you that option, but you're not going to select like A, B, or A, C or something. I think we have one more after this. ready to go on this one? That's D, right? Any other thoughts? Are we all saying D? Remember, we can pick other ones too. Sonia's also saying B.
All of them.
All of them?
Yes.
Let me zoom back up. Alright, do we all agree that it's definitely not D?
Yeah.
Like, I mean, D meets the, let me say it better. D definitely isn't gonna work, right? So definitely that one. Well, okay. Like our limit as x approaches 4 over there is nowhere near 10 root 2. Okay. Let's go through the others in order. So limit as x approaches negative 4 from the right is 10 root 2. Could that still be that the limit overall is 10 root 2?
Yeah.
Yeah, so we don't want to select that one because this is could not represent. How about this one? I mean, does this tell us anything about a limit? Sorry. We have no clue on that one, right? So it could be 10 root 2. This just doesn't give us enough information. Okay, how about this one? The piecewise one-sided limit. If we come in from the left, what is our limit? Oh, I didn't get a response there.
10 or 2.
So that one from the left is fine. And then from the right, what do you get? Okay, so we just have to interpret if that meets the condition. By the way, is anybody else getting sick of writing the limits down?
Yes.
If you're writing them out as you should be, this gets super old for sure. All right, so we have one coming from the left and one coming from the right, which is 12 root 2. So this one is not this, right? So you should have chose C and D. Anybody? I couldn't tell because people are mostly holding up one letter. Raise your hand if you got that. All right, man, good job. All right, last one.
What A and B?
All right, so if we look at the pattern in the table, we're going up by 0.1. And so 7, 8, 9, and then 2. Remember, we're trying to figure out if the limit is 2. Here, we're going up, coming back to the limit, we're going up by 2, well, 0.2, so the next number would be 2. So does the table work? Well, we only checked one thing, which was the graph pattern or the table pattern giving us the correct limit. What else do we need to check? Yeah, does it match the description? And it says the function is increasing. That's decreasing right there. Okay, so that kicks out A because it's not 1, B, and C. So by test strategy, you could just go with C at this point. But let's make sure we're clear. The limit from the left is 2 and from the right, so this one works. And then here, is this function increasing? We still need to check that. But then also, does the limit equal 2? And yes, it does. So be careful with those tables. They've got to match both things, the limit, pattern, and the description. I think that's all. Yeah. So then we have the problems in your notes. Let me ask you before I assign anything. Do you, going back to 1/8, this kind of stuff, squeeze theorem, do you need practice on that? Or are you feeling pretty good with it? Be honest with yourself. Okay, alright, so I'm not going to assign any squeeze theorem practice. There is, the answer key is going to be posted. You can check if you want to do some of the problems. But in this packet, let's go ahead and do some of these. And you'll notice there's no test prep for this. So why don't we just do the odd ones? We'll see if that's enough. You can always do more. So just the odd ones out of section 1-9. And then again, I'm gonna, how many of you need an extension on the review deadline. Okay, so a few of you. So like tomorrow, does that work? Okay.
What are,